start. So thanks again for being here on your Saturday morning. I'm going to be sharing with you the MDTP Assessment System, which is a free system that we are supported by the by CAP, which is the California Academic Partnership Program, and it's an umbrella under the CSU and the UC systems. So we get grant funding every year to do the work we do. We provide everything we do free of charge to all secondary math educators in the state of California. We've been doing this since 1977. MDTP started writing its first diagnostic test at the college level. A few UC professors got together and wrote a calculus readiness test. And then once the high schools got wind of it, they said, write us some. And so now we're offer tests all the way down to sixth grade assessments of readiness for sixth grade math. And we have been grant funded since 1984, just in case you wanted to know. I personally have been a longtime MDTP user. While I'm the statewide director and I'm located in a director's office at UC San Diego, I taught with Carol and I taught with Ron at San Diego Unified for 13 years. I taught with others in Northern California, El Dorado Unified for I taught 13 years in San Diego Unified and 7 years in El Dorado Unified School District. So 20 years math experience, high school, mostly 2 years of middle school, used MDTP for 13 of those years, which is probably why I'm doing what I'm doing now. So the rest of you, I really thank you for considering using MDTP and all the different resources we have. Okay, so the first things we'll talk about is diagnostic tests. We have open response items, we have learning modules, and of course, this is all free of charge. I'm going to talk pretty quickly for the while, and a bit I'm going to ask you to do a couple math problems. So if you don't have pen and pencil next to you, you might want to get a few, just so that when we get to the diagnostic test data, you'll know how to analyze that data, and I'll make you do a little bit of thinking. Okay. All right. The first thing that we provide is that one of the oldest resources started, like I said, we started writing our readiness tests in 1977. And we now have levels all the way down to sixth grade. So we have assessments of preparedness for middle school, and we have readiness tests for course level tests starting Algebra 1 through Calculus. These tests are diagnostic in that they do provide you with data. So this data helps you measure your students' preparation and readiness for the course they're entering, or as we are right now in the spring, the course they're promoting to. So this is a really good time to be thinking about the next course, where they're going. And in fact, what I'm going to be doing today in my session is kind of sharing with you an experience I had to teach a bridging course and using MDTP to guide me through the focus, and then how I determined what I was going to be teaching in a very short amount of time and the results of that. It also helps us to understand how the students' competency in important topics. So MDTP aligns their diagnostic test along foundational topics of mathematics, and we look at the progressions from the framework to determine how these topics inform college readiness for mathematics. The diagnostic feedback is very robust. We can use it for lots of purposes. We can use it to inform our instructional design, our program design, our lesson design, helps us learn about potential misconceptions and potential gaps, and also strengths of student learning. And it can be administered. These tests can be given any time of the year. We provide them online, which is what we strongly advocate, is using online testing, but we now have paper test available again because you guys are in with your students, and paper testing is now scored through our online system. So you will be getting if you give a paper test, you will be getting results just like you gave the online test. Your results would be instant, and they would be in the online platform, so you can click and you can drill into it. We also have designed a demo test for each of the levels. And these are just 3 questions that you can sign ahead of time to help your students see the expectation of what it's like to take an MDTP test. And also for you, so it's like a practice. So you could say, okay, we're going to take these three problems. You could talk with students through it. The demo tests are designed to see different types of questions, like one you might need to scroll that has a lot of figures, one that needs to have math on paper. So you have the students do the math on the paper, so showing their work. And then one that might have a different types of answer choices, like choose what A and B or B only, things like that, just to give them some ideas of modality of testing. It's not a practice test. It doesn't prepare the students to take an MDT test content-wise. It is a test run. So it's a demo. It's like you're demonstrating how the test will work. I advocate for those to help you also understand how it works, proctoring a test, getting the code, getting the students logged in so that you have that little practice time ahead of time. Okay, the next thing that we created, we started this in 2015, started designing these tests 2016 that were aligned to the SB 359 mandate. We have 3 different assessments: the 9th grade assessments for students exiting grade 8, the geometry assessment for students exiting Algebra 1, and also the integrated second year for students who are currently in integrated Math 1 and exiting Math 1 to see if they're ready for integrated Math 2. All of our tests can be ordered. These links here, we will be, the session is recorded. We will also have this posted online, this presentation with these links available. And at the end, I'll try to take you into the MDTP website so that you can see what it looks like, where you can find all of our resources. Like I said, we designed these tests specifically because, as I said, I used to use MDTP quite a bit. And the readiness test, to me, should serve a different purpose than a exit test that's going to inform the Placement Act. So SB 359 is a mandate that says that all students entering to 9th grade must have a clear, transparent, and equitable placement policy in place for them. And when I first started working in this role, people were calling me and saying, what test do we give? What MDTP tests do we give? So this is why we created these 3 different tests. Miliano and I will talk deeply about this in our session if you're interested in the readiness versus these assessments, the 9th grade assessments. They are designed to be used as one of multiple measures to inform options for course enrollment towards college preparedness. And they also are diagnostic. So they're part of our diagnostic system. You can use the data at the end of the year at 8th grade to see how your students are doing. Do you need to inform best for your program reflection? You need to create a new design, maybe thinking we were strong in these, but we need to provide more support for students to bridge maybe something that they had found more challenge towards in topic wise, or even just in general. These are only available online. We do not offer these as paper. We do not print these tests. We try to keep these just a little bit more secure that way. And then one of the things we also have are open response items. So one of the things that I know Pat and Carol have heard talking to teachers this year is that teachers are tired of doing, and students tired of doing math on paper, online, on a computer. So our open response items gives you a chance to print something out, give it to them paper pencil, and you can write things out. Carol and Pat will be talking specifically about written response items and our open response items. We have a new one, which is my next slide, specifically looking at some of those items. I highly recommend that if you're interested in that type of a formative assessment. We do have new items available for field testing. We need your help. We need some teachers to try these out and to score them and send us back some student examples just so we can look at them with our work group. We meet every June. We write new tests. We look at data. And this is how we keep MDTP with new things. The written response items are intended to be very conceptually rich and then engage students in a way of thinking so that they have to communicate their reasoning. And they can be given, they're multiple range. You can also be given, one problem can be given from 6th grade all the way through calculus, depending on what students might need re-engagement with. They support a focused so you can learn about students what they know about an MDTP topic. So diagnostic data gives you preliminary data. These can dig into what students might be thinking and more focused, and again, conceptually to see what they're thinking conceptually. And then also they provide lots of opportunities for students to reason and to dialogue if you want to share student thinking. This is a great formative assessment, but it's also a really good learning experience to be given in the classroom. And there's lots of strategies for how you can use MDTP tests that we have on our website. and that we did some webinars on last year. They do also come with a 4-point rubric, which supports performance assessment expectations, just to get the students' idea about how using a 4-point rubric works. This is a good time to be thinking about that, because I know you're working on Smarter Balance coming up with their performance task. And then their new thing is brand new. We wrote FCRIs, which is, because it's hard to say it, formative constructed response items. And we did that last summer, and these are aligned to the algebra readiness test right now. But these are, we looked at items on that test. We looked at what students were thinking, what we diagnosed. I'll talk about that in a little bit. And then we created parallel problems for you to come back to after you've done some intervention. So if you want just a quick check-in. So these are supposed to be short, focused post-intervention assessments, so that you can see, do the students have it? I learned something with the diagnostic data, I did something about it, and I want to do a quick check-in. They are to be administered after you've given, they're intended after you've given an MDTP test, and then you've diagnosed that test, and then you've done some post-testing intervention, and they should be actively proctored. You should be using them when you're proctoring. Okay, see something in the chat. Okay, so we're getting, thank you for sharing the sites for there. So yes, these websites are only intended for vetted secondary math educators, elementary math educators, teachers. These are not for tutor groups. These are not for students. These are not for parents. These are for you. So we do vet them. So if you have these links, please do, you may share them with your colleagues, but please do not share them with teachers, tutors, or students. I mean, sorry, with parents, tutors, or students. You may share them with teachers. Okay, thank you. Thank you, Lang. Okay, and learning modules. This is something also maybe new for some of you to learn, that we did create several. I think we have about 15 modules right now that we have posted online. These were designed to support students independently. Again, after we learn something about results along a topic, an MDTP topic. We designed these for Summer Bridge program at UC San Diego. Students coming in, we looked at the pre-calculus readiness test, which at the time and still is called the math analysis readiness test. And we found that some students may not be quite ready for the program we had designed for them in math. So the learning modules were a way for us to bridge some of that knowledge. I did use learning modules in the bridge that I created, that I taught recently, but these are for students to do independently. We won't be talking about the learning modules in this particular sessions today. So I welcome you to go ahead and check those out on our website. Each model is divided into lessons, probably 3 to 5 lessons each. And what they do is they unpack some sort of knowledge, generally misconception, back to where that misconception may have been started, and the math behind it. So if the students, or we're bridging students into a pre-calculus class, it might be that they had a misconception that was originated in 6th grade math. We would go back to the 6th grade math, and then we bridge that math, the modules would bridge all the way back up to a pre-calculus level. So we'll not keep them in that level. They are components are explore, try this, watch this, making connections and practice. Just these are all designed to be conceptually engaging for students, and not like an Alex type program where you see a lot of problems a lot of times and they practice a lot of problems and then they move on. These are more of a conceptual building. And they, like I said, we unpack that, the misconception, and we remedy it, and then we bridge it back. Okay, so at this point, I'm just going to give you a little bit of an idea about how you could be using MDTP in your course right now, the different ways to use some of our assessments, specifically the diagnostic testing. And I chose the Algebra 1 integrated math course. So students are currently in this course. I choose this because we have a lot of middle school and we have a lot of high school. So this is a common course, common ground here. Students entering into an Algebra 1 course. So in the fall, we recommend that they take the integrated math 1 readiness test. This is going to inform their readiness for the math, the topics in your course. gives you baseline data. So at this point, you would be identifying strengths to build on, misconceptions, and potential gaps, which you would need to remedy and intervene on. And then depending on how students do on that first fall administration of the readiness test, you would then consider, would it be helpful to you to give the same test to the same students to see if you can check some growth? And if your students, remember this is Algebra 1 readiness, so these are not Algebra 1 topics, but in 2 to 4 months, if you've done some real intervention and you want to see how your students are growing, then you could assign the same test again in 2 to 4 months on the online platform. It does a comparison analysis. Another thing that you could do is that you could give them an FCRI, which Carol and Pat will be talking a lot about in their session. And those are aligned to specific items. If you want to do just a quick check, I've done a lot of work on a particular topic or concept or skill. I want to see if my students have it. That's another option for a post test or this would be a mid-test check. The next thing you could consider is that if your students are moving on to geometry, they should be from Algebra 1, Geometry, Integrated Math 2, then you could give them either the Geometry Readiness Test or the Integrated Math 2 Readiness Test. And this could be checking to see, again, baseline data for their next course readiness. So this is kind of where we are right now. We get baseline data for where they're going to be going to. So how ready are my students for the next level? And this could help focus my instruction on the most important things to get them ready when they exit my class. Then you could follow up with the same test again. So you could do a pre-post analysis on their check for growth from their mid-year testing. And you could also see now after you've run your coursework, how your student readiness is for the next level. So program design, summer PDs, trying to figure out what you're going to be doing in the next year. So we do have these recommendations for all levels, starting with students exiting 5th grade through students entering calculus. This is available on our website, and our website's pretty robust. So Pat, Carol, can one of you guys just type in the chat our website? So if anybody wants to kind of multitask and kind of check in and out of there, this would be on a resource under assessments of preparedness and readiness tests, if you scroll to the bottom. All right, let's get into some data. So MDTP, we have a work group that is a pretty robust group of educators across the state. We have faculty from the community colleges. We have faculty from CSU and UC, and we have faculty from middle school, high school. We have district TOSAs, we have administrators, we have consultants from ETS who join us every week to help design our tests. We have a lot of fun with designing diagnostic tests because we try to create items that help us measure what students are thinking in a multiple choice test. So creating the STEM is really fun and really easy, but creating the options are something that we highly enjoy, that engagement. And so we're looking if we can learn something from an item about how students are doing in prerequisite skills and what we know that they need to be successful in the course they're in or the course they're promoting to. The diagnostic tests help us to identify 3 things. We can look at their strengths, their unfinished learning, and potential gaps of content knowledge. And so when we get a diagnostic test, then we can get into that data. We'll be doing that first. So the whole purpose of our time together today is to think about next course readiness. That's the goal. How do we know that? So from now working forward, I'm going to be sharing with you some of my experiences with teaching a summer bridge program for students that were entering into a pre-calculus course in the fall. They were exiting high school and they weren't ready for pre-calculus yet. So I'll be talking about my different strategies for teaching an 8-week program. This is based on defining the math, the most important things that students need to know to be ready for that level. So first of all, we conduct a baseline data analysis. Then we determine the math that students do know and we build on that. That's really important. And then we also think about the math that students need to know to be successful in this course and also the next course. So that's also a balancing. In this course, the math they need to know And if for some reason they have something we've identified in data that shows that you need to intervene with that data so that they can access your current content. The math they need to know when they move on. How are you going to bridge that between now and when they exit your course? So that's what the focus. Carol, Pat, anything I need to stop and answer? You doing okay in the chat?
Okay.
All righty. Gave me a little breather there. Okay, let's get going. Carol, Pat, can you guys give me a 10-minute warning? Thank you.
Oh, sure.
Thank you. Okay, so the first thing we do when we give an MDTP test, a diagnostic test, is that we get whole class topic performance on the test. So MDTP designs each of their tests along the major topics of math. This was a specific performance for the course that I taught, that bridging course that I taught. And this was taught in the summer of 2020, and it was a 100% remote program, just so you know. You'll see me talking about how students entered their different assignments into Canvas, which was our learning management system. And I know a lot of you are using Canvas, using Google Classrooms, using all kinds of LMS systems and getting students to be able to get data to you. This particular topic performance here, you can see, is done by percent correct. So students this was a bridging. This was an MDTP test designed specifically for this course offered at UC San Diego. And we created 4 cohort tests that we use, and we've tested about, I'd say at this time, 20,000 students from this bridging course all the way through Calculus 2. So we do have now a Calculus 2 readiness test that we can be using at the post-secondary level. So you can see the topics here are pretty diverse. Also, another thing you learn about is how many items are in each topic and what is the critical level. So if we look specifically at decimals, that our first topic, there's 5 items in decimals and percentages, absolute values. And students need to earn a 3. Sorry, here, click here. There we go. A 3 to be deemed meeting the critical level. And MDTP determines the critical levels. In our summer conference, we determine critical levels. And this is what we consider students should be answering the number correct to be minimally prepared. I actually say maximally prepared. If they're meeting critical level, they're going to do very well in your course. To be ready for the topics in your course now, okay, or the topics in the course they're moving to. And then we also show the percent of students meeting critical levels. So as you can see, this particular class, 81% of the students did well in this topic, the first topic. And then what we use this for is to get baseline data to basically what I used it for was to design a unit. So my first unit was going to be on basically solving linear equations and working on linear functions. So in order to do that, I would look at specific top items in a topic. I wouldn't look at all the data at once. You could do it, just to kind of think about what you're going to be doing, but you would pick some topics. So it makes sense. I would look at fractions. It makes sense. I would look at functions because I'm doing linear functions. It also makes sense. I would look at items in the linear equations and inequalities topic to see what students are thinking. So we're going to dig into some of those. So this is the topic on linear equations, inequalities, their graphs and absolute values. So you click into a topic, it shows you the items. We'll notice that there's a range of competency on these. So we have an item students did really well. Almost 100% of the students got it correct. And we have items that students didn't do as well. In fact, almost less than 10% got correct. So let's think about those. These items that students do really well are these strengths. We'll talk about that and getting some common language when you go to work with Pat and Carol in the next session. They are going to be thinking about the way of classifying items. Items that they are getting, less than 20% correct are these gaps. What do we think of as being gaps? And then what's going on with items in the middle? This is unfinished learning. What does that mean? So we'll take you into some data, and we'll give you some language.
Excuse me, Kim. There's a question, and so the question about the students who took the test. Were they selected at a lower level or known to struggle, or were they expected to be ready?
So these are students who took, all students have to meet a prerequisite to enroll in math at UC San Diego. So these students were identified as needing a bridging based on placement exam. It is an MDTP placement test. So these were students who were recommended to be in a bridging course so that they could be ready for pre-calculus when they entered in the fall. Good question, Carol. Yes. Well, and it's generally we have a fairly small group of students that are in this category at UCSD, but we have students that are at all levels, and we want to meet students where they are. So if we have data, I want to help us to determine what is a strength and what are the other pieces here. So how do we look at that? So if the student has a strength, that's an item where most of the students answered that item correctly, and that makes sense. Okay, and then what is unfinished learning? Well, I think of this two different ways. I think of this as being a misconception or an informed guess. I think, well, how is an informed guess unfinished learning? Generally, if a student shows you a misconception, a lot of students are choosing the same wrong option, wrong answer. And that's a common misconception, and we see it a lot in fractions. We see it in inequalities. We see it in factoring. We see common misconceptions that pop up in some of those topics. Informed guess is where it looks like the students are guessing that they're all selected randomly, the options, but generally these items are more procedural in nature. So there's a procedure that students may have tried to memorize, but they have not mastered the actual competency of completing that procedure correctly. So something in a response resonates with them, but it is not the actual correct answer. So this is where you're thinking this is unfinished learning. Then what is a gap? What do we consider a gap? So in MDTP data, we ask students that if you don't know an answer, do not answer it. If you don't know a question, don't answer it. We do that because if they are just clicking and answering, they could get 20% could get it correct, and that's going to mess up our diagnostics. So we ask them not to answer items that they don't know. Now, if they actually know a question, they've seen it before and they have some tools, they should try it. But if they're in an Algebra 1 course and they have been given a log test, maybe a placement test of some sort, like I was talking about, and their background does not support that, they should not answer that question. Then we know that they've omitted it at a high rate, and that's a gap. Okay, let's dig in some data. So this data here we see was that one that I clicked on first that gave 96% of the students got this correct. And so I had designed in advance a bunch of lessons in linear, and one of the lessons I had was translating words to expressions or equations. And I thought I had to go through the whole process of breaking it down. When I saw that my students got 96% correct, I said, no, I don't need to do that. That I can build on this. This is a lesson I tossed. Give me more time. So definitely students know it. You don't have to do it again because it's in your curriculum or it's on your pacing guide. You can just delete it and move on and build on it. You might give just a warm-up question or something which re-engages in you the previous learning, prior learning. Let's look at some components of this item. Omitted. This is question 6. All the students answered this question. Not seen. All the students saw this question. These are totally different data. So not seen means that they didn't finish, they did not even see the problem. Okay. Another thing we look at is the answer correct. So 96% of the students answered this correctly. And it looks like we have 1 or 2 students or a small group of students that didn't answer this question correctly, the misconception. And if you look at the misconception, they just organized the information incorrectly with the slope and the intercept, which is a common misconception at all levels. None of the other options were chosen, so this is definitely a strength for students. So the next item I chose to look at was this item here, and I'd like for you actually to quickly, I said pen and pencil, can you do this problem on the side for a moment? And then could you tell me, just have it sitting there and we'll talk about this. Let's first see if you guys get the same answer. Make sure you give us a key here. So can you give you a minute? If you want to use a reaction, you can give me thumbs up when you're done. You can use your reaction on. or you can just give me a thumbs up when you're done. Excellent. Excellent. Done. You can put it in the chat too. Thank you.
We've got lots of dones and smiley faces.
Awesome. Sounds great. Okay. So first thing we'll do is got a chance to scroll through the faces because I can only see a few when I'm presenting. So I do want to do a call out for another MDTP person, Deanna Kahn. Welcome, Deanna. Deanna's here. She works with Carol in the UC San Diego office, supports the San Diego region. So Deanna's here. If anybody else pops in, please let us know. Okay. So we were looking at omitted versus not seen. This is question 35. There are 40 questions on this test. So 40 questions means that most of the students probably finished this test, but there's 4% probably didn't finish the test. Not seen means they didn't get to this question. It was a time test. 12% omitted it, which means that they decided these are not the not seens. They decided not to answer this question for whatever reason that is. We also see that 42% of the students got this correct. And we see that 23% of the students answered 13. So can you place in the chat or unmute yourself and call it out? What do you think happened if students, what's the math that students did to get the answer of 13? What do students know to choose this option?
So several ideas in the chat, changing subtraction to addition because it has to be positive, of course. Doing 4 plus 9 instead of 4 minus 9. Added the 4 and the 9 instead of subtracting. Forgot to subtract 9 from 4.
Mm-hmm.
Excellent. So now you are now thinking about how we design these tests, and we should invite you to our summer conference because we're going to be designing a bunch of new tests this summer, which is this is great. One thing on our agenda is 7th and 8th grade assessments because we released those in 2015. So it's time for us to get started again. We do work on new tests for about 3 years. We get field test data and highly vet those tests. Pat was the first MDTP person to chair a middle school test. She was the committee chair for the pre-algebra readiness test as my work group. So thank you, Pat. Okay, so you can see there is a misconception here that a good portion of students got this correct, but we still had students choosing other items. We had students omitting this, and we also had a misconception design. So this is something I would need to intervene on in my class. And let's take it one more step here in the absolute value piece. We had to add to it an absolute value inequality. So as you can see on this particular problem, there was a lot more that happened with this group on this problem. In fact, what does it need when they omitted it at this high rate? What do you think? In the chat, open your mic. What do you guys think?
Didn't think they had the skills to even attempt it. Unfinished learning. Some might have thought it was too much work.
That could
They
be.
knew something.
They did think something. This is question 22. It's in the middle of the test. All the students saw it. They didn't know how to solve it. So they just made a choice for whatever it is. And a lot of students, knowing that they are going to be taking, so this was a pre-test. So I should explain this. I gave this to my students the first week of our bridge program. So they're already in my class. And so omitting at a high rate for me as the instructor meant that they wanted for me to focus on this, that they believe this is something that could help them learn more about. So there's definitely, we worked a lot on absolute value, but specifically we started with inequality. Question though, a lot of students are likely to guess at random when they don't know how to answer. So that's when we said this is unfinished learning, when they're guessing at random, because they've seen it before. And you're correct, because if you look here, we've got several things going on with misconceptions. They're choosing A, pretty high percent, right? They're choosing C, a pretty high percent. Those are definite misconceptions about absolute value and even inequality, about just thinking about what does it mean to be an absolute value. So you're correct. All of these things are what students are thinking. This, to me, I consider to be unfinished learning and somewhat could be a gap, because we had a high omittance, so students aren't comfortable with the content, but also there's misconception around absolute value and even inequality. And more of the data I looked at showed me that inequality was also something they had a strong misconception around. It wasn't that they had never seen it before, it was that they had misconceptions. So it was unfinished learning. Okay. So what we're going to do is kind of dig into what we're looking at, some of these items and what I did about them. But specifically, this last one here is from a different topic. This was from fractions, and this was a curious topic. This was a curious problem for me, because 35% of students got this correct, but low percent omitted it. So this is question 5, but we still had a few that decided not to do this problem. Maybe because, like some of you said, maybe it takes too much work. They thought it would take too much work to do it, but all of them saw it, and 35% got this correct. But we have a high rate choosing A, and that was something that I know that there are a few of us on this call today saying, why do students choose 3/4? What do you think? We'd like to know what you think. I want to do what my students thought, but why would they choose 3/4 as their highest option? Definitely misconception.
A is a fraction they understand.
Exactly.
They're more familiar with 3/4. They can see it more than 11/12. It's recognizable.
Right. So all these are really great things. We had this conversation also. In fact, this is an item that is field tested as a written response item and as an FCRI. The smallest denominator. Yeah, that was something we thought a lot about. I think a lot about that too, because it doesn't mean if it's the denominator is smaller, it means the piece is bigger. So they're looking at, the part instead of the whole, parts of a whole. Yes, so there's all kinds of things going on with this problem, which made it a really great opportunity to write a written response item and a formative constructive response items on this problem alone. Okay. So now that I have some data to look at, what I would challenge each of you to think about right now is a focus. We have a very finite amount of time. Like I said, I had 8 weeks. You have a finite amount of time between now and the time that you end with the students that you have right now. So what I have done in the past when I worked with groups of teachers, and I would say I was department chair for about 17 of the 20 years I taught in secondary math. We would always meet at the end of the year about now, and we would think, okay, where are we and where do we need to go and how do we focus? What is the most important things my students need to know to leave me and be successful in the next level? Very great conversation to have with the people in the room around you. Maybe you're an Algebra 1 teacher sending your students to geometry, then you need to be in the room together and talking about that. We make decisions together. This is what we're going to be doing. So working with your content peers, identifying those most important concepts, topics, and skills, and then give them a name. So when I did this in the past, we call them the Big 10 in my school district, but they could be big ideas, go along with the framework. I hear a lot essential learning objectives. So these are giving them a name, clumping them those big ideas, right? We also created exit level benchmarks or our one problem assessment that's going to be checking in on how we're doing. Once we've defined them, we create those exit level, and then you can build your curriculum around it, around those essential learnings. Your textbook is a book. It's flat. The words don't pop out and let you know what's more important other than when they're bold or they're colored, right? So it's up to us as educators to define the flat curriculum. There's a myth that everything in this book is important as everything else. We need to define what's the most important. We need to pull those most important topics and skills up out of that flat book. We need to make peaks and valleys. Those peaks are things we should actually spend more time on, develop deeply. The valleys might be some things that if we spent a lot of time on the peaks, we might not need to cover. Textbooks are designed for coverage. They're not always designed for understanding. I'm not gonna say 100% of those because I know Pat works with CPM and they do think a lot about spiraling and thinking about conceptual understanding. But some curriculum are designed to get you through, to check it off. So it's up to us as educators to make our definition of not everything is weighted equally and what are the most important things. Also, in my experience, I didn't always align with the topics. So how they align things wasn't necessarily resonating with me in the way I wanted to develop conceptual understanding. So I might reorganize the topics. And then you need to figure out what are you going to do in your curriculum to support what you've decided that all students need to know when they leave your class. The other thing is that you can use MDTP assessments formatively. So you don't have to just get a number and a score and think about readiness now or yet. You could be thinking about how they're merging and how the learning is emerging. Okay, so here's an example. Said I taught an 8-week class. I decided that I would focus on 3 function families: linear, exponential, and quadratic in those 8 weeks. So I had 8 weeks. I met with students 3 days in the week for an hour and a half. And then they met with a discussion section that kind of just recapped and answered questions for students. And I also had office hours. So this is what we focused on to get them ready for pre-calculus. And I got the baseline data, which I showed you. And I looked for things like strengths. What I learned that students did really well was they translated words to expressions, dumped that lesson. They did very well with solving one variable equations. So I could build on that rather than designing the lessons of how the balance works, how you undo things. We didn't have to talk there. We can dive right in, give them a problem that I wanted them to be able to solve and go and build on that instead of developing to that level. Unfinished learning. My students had a lot of unfinished learning on fractions and integers, even order of operations, solving systems of equations. So it was evident in the data that they had seen this before, but it was unfinished. They had not achieved mastery. And solving multiple step problems. So giving them opportunity to say, did you answer the question? Going back, making sure they've completed all the steps. Definitely data showed me that inequalities and absolute value were the main gaps in the content that I was planning to present to them. So now we need to figure out, I've got my objectives, I've defined my curriculum or my essential learning. How do I get to the next step? So I need to build the bridge, right? Here's MDTP strategies. These are the things that we've kind of developed. We talk about in our sessions together. Embed mini lessons. None of us here advocate that you learn something and you shut down what you're currently teaching and you do boot camp fractions. It's not going to help. What we do recommend is that you keep on your pace. You keep doing what you need to do, but you embed the mini lessons as you need them. So necessitate the learning. We don't do fractions just because they're here. We do them because it's going to help us with what we're doing today in our math course. All right. Make your learning transparent to students. A lot of us take a lot of time to build really great lessons. We do. And when you notice at the end of your lesson, you go, whew, it all worked out, right? You feel really great. We've also had some that are like, we were challenged in the middle of. I've often found that I sweat from my knees sometimes when the lesson doesn't work quite right, but that's okay because it's a learning experience for all of us. But when we get those really great lessons, we do a lot of backwards planning. We do a lot of thinking. Go ahead and let the students know what you're thinking about that. Because sometimes to them, it seems like math magic when it all works out for us and we say, oh, that was great. The students are still, you look at them and sometimes they're still like, how did she get there? How did they get there? So all the things that we put into our lesson planning, let the students know, because then they are actually part of that scheme and our framework for thinking for how things work together, making connections to prior learning, to what we did yesterday versus today. And then another strategy is to provide multiple opportunities for mastery. In the brain research, it takes us about 6 months to really retain long-term learning. So when you teach something to your student today and you give them an exit ticket, they all have it. you're like, great, that was great, I got it. And then tomorrow you come back, if you gave the same exit ticket without revisiting that content, they would be about 90% less in retention. And you'd think, wait a minute, they had it yesterday, what happened? It's not you and it's not them, it's us, right? It's our brain, it's the way we learn. We need to keep doing it and keep practicing. That's why an athlete takes tons of practice to get really good. The brain's the same way. We need to continue to see these over time and repeatedly to be able to go from short term to long term. Cramming for a test takes something in short term. Getting an A on a test doesn't mean students have mastered it, just so you know. Took me a couple years to figure that out in teaching. Okay. Then I promised you I'd share some things about my own personal strategies. So I make math messy. I distribute the learning over time. I use the written response items, the learning modules, building on student thinking. And then I had the students write parallel problems, and because we did not have the SCRIs when I taught this course, but we have them now. Pat and Carol will talk to you about how those were designed and then what they can do. All right, so what does that mean? Make math messy. I did see, as I unfinished learning was fractions. Students in my course were not allowed to use a calculator, and well, when they promote to pre-calculus did not allow students to use calculator on their assessments, or in calculus, they have to take tests without calculator. So they have to be mastered and proficient and procedurally strong in fractions. So every time I gave a problem, I wrote it so that its answer was a fraction, or I used fractions, area perimeters, we had fractions. So they were doing operations on fractions in the problem. I took notes whenever we'd solve it. This is a mathematician solving it, and did many lessons all the time with fractions with uncommon denominators, because that was something that I really noticed. I also made students check all of their answers. So they had to plug it back in without a calculators. I did it on their tests, their midterms, their quizzes, and their final, so that they had to become, and they did it every day on their homework also. So they were constantly always using them and practicing. It paid off pretty well. Then I also kind of evolved to something that was not one of the topics. My topic was definitely not using rational functions or rational expressions. But because we were using fractions every day, I bridged it in warm-ups. So I'd give a warm-up. One day would be 2/5 plus 3/4, and adding them. And then I would give the next day, as we keep going, 2a/6 plus a/5. I'm getting the concept of a rational expression in there, but being able to reproduce the same skill knowledge to answer the problem. And then evolved, after we did factoring, we evolved to solving rational expressions by adding them together with uncommon denominators. And this is something the students we would do in a warm-up in breakout groups. It was not part of the lesson, but it was keeping it alive and moving it along, distributing it over time. I also really wanted to know what was going on with this problem. So I assigned my students the written response item, which is a field test. And like I said, Pat and Carol will talk about these in depth. These are on a field test works website. And if you use these, we really do ask for you to give us some data, because we'd like to see this. But if you look at this, it says Ronnie's convinced 3/4 greater than 7/8. Mimi's convinced that 7/8 is greater than 3/4, who's correct. So it's walking through, it's breaking apart that one problem where they had to order into smaller pieces. And then at the end, it's like putting it all back together. Students, like I said, they did this, they did this as an assignment at home, and they loaded it up onto our learning management system. So they took a picture of it, and they just loaded their picture up on the assignment that I had put in there. So I had two examples. I deleted one for time, but this is an example with one of my students that used diagrams and also found common denominators. So one of the great things about written response items is it gives us a way to think about what students are thinking. Because we had done intervention, I gave this in the second week of class. The students had time to re-engage with content around fractions, and they did very well on this. So it was more for me to see, now we've done some things, I want to get a check-in, a formative check, without giving that test item to students again. So this is what I did. I see some chats. Did anybody need me to stop here?
Nope, we're good.
Okay, awesome. Great. Okay. Learning modules. I did have students do lessons from the learning modules because I told you I spent an hour and a half with my students 3 times a week. So I didn't have a lot of classroom time. The learning modules gave them opportunity to get into something a little more deeply. So explore, try this, watch. So the videos on the Explorer is always like a what do you notice, what do you wonder type of thing. Try this is basically what we would say is guided practice. Watch means that they've seen it a few ways. Now they could look at maybe a Learn Zillion video to see it a conceptual way, a different way, making connections, kind of putting it together. And then they always ended with a practice. Now, these are not completely in order. We always started with an Explorer, we end with a practice, but the other pieces in there also could be repeating in and out of the modules. So this is a modules on patterning. And this is for linear. This is our first week. Patterns, what do you notice? What do you wonder? And in the first lesson, they try this. There was 5 different patterns that were explored. And there was a graphic organizer that they could download to give them this problem. I assigned this particular problem to my class to do for homework. And they could look at the other examples and try this. So they could do patterns 1 and 2, and they can come back with 4 and 5 if they wanted more practice. And this is what it looks like. The student downloaded parts of the graphic organizer and filled those, took a picture, and for the steps, so they had to draw step 0. They had to graph the relationship between each step and the number of squares that are shaded. And then they had to answer questions in there about write in your own words, what is the growth pattern, complete the table, and then write an equation, and then find how many squares would be shaded in the step 100. So this gave me a really great opportunity to come back in here and build on student thinking, because we had just finished looking at function notation. So you notice the student said S equals 3n plus 2, and also gave S of n is equal to 3 equals 3n plus 2. So 2 different ways of writing this. We can also talk about what does that mean. Domain, what is n? Is that a finite, is it a continuous domain? And when you're talking about a continuous domain, then when they graph it, does it make sense to draw the line? So these are things that we could talk about naturally based on student work. So we weren't talking about discrete versus, points. This is discrete points versus continuous points, but we were talking about domains. So let's give you an example of how we can consider that. So this is really great. Another thing I had my students do is writing parallel problems. So instead of me doing all the work for midterm to give them a test review worksheet, which a lot of teachers spend a lot of time say, what's on the test? And we give you review problems. What I did was I gave them the specifications. I told them, give them a blueprint. This is what's going to be. These are the topics on the midterm. All right. And then I said, I want you to create exit level problems given the determined content. And so I paired them up, and we use Slack during this time. I don't know if some of you guys knew Slack. So I paired them up into partner pairs, and the partner pairs were to design 2 problems. I told them if their problems met the test of, if they were competent enough, that I'd already written the midterm, but I would swap their problems out and put them on the midterm if they were the level that I would be testing. So what the students are thinking now is, what is she going to test me? What does she think I need to know? So they're doing the cognition they need to prepare on their own. And that metacognition where they're actually checking in with each other to say, am I on track here? Once they wrote their 2 problems, they swapped their problems with a pair. So I actually did partner pairs with 4. So I created Slack channels with the 2 and then with 4. And I was part of those channels so I could see their interactions. The other pair was to vet their problems, take the problems, make sure that they made sense, if they needed any revisions, give them back, say, I didn't understand, please rewrite this, answer it. And then the authoring pair would get that feedback and would revise their problems. And then they would be submitting a revision to me as part of an assignment to prepare for the midterm. Again, we use Slack channels so I could watch their dialogue, because part of that project for the midterm was that they are communicating with each other. So I can evidence that communication back and forth, because again, we were all online. And then, so this was my way of writing parallel problems. Now, it's great for you to have students do this. It's a wonderful lesson to spend getting ready for tests, but we also have done that ourselves with MDTP with the formative constructive response items that, again, Pat and Carol will be talking about later. There's a few things in chat. Do I need to address?
It's time. It's 10 o'clock, 10:01.
My session goes to 10:15.
Okay, perfect.
Yay!
Yay!
Yeah, so I'm right on track. Thank you,
Okay.
Carol. So yeah,
Okay.
I get to go to 10:15.
Oh, perfect. Okay.
Okay, so what I said in the beginning is I'm going to talk about MDTP, what we offer. I'm going to drill into some diagnostic data. I'm going to show you some things that I do, some strategies of looking at baseline data and figuring out to be focused and coherent. So now you're going to see the results. So I showed you some items that my students had done, and now we're going to look at results. So I had the students take the exact same test. This was at the pre-test and mid. So 8 weeks, after 4 weeks, they took the same test again. At the end of my program, I gave them the pre-calculus readiness test because I wanted to see how ready they were for pre-calculus. But since I had been doing a lot of intervention in the bridge program, I wanted to see between what they first came in on that baseline test to after 4 weeks. And you can see that we made pretty good gains on all the topics, except for geometry, which was also a reflection for me, even at the end of my program, is I didn't have time to do that. And you will too. So for me, I was like something I had to give up. But if I were to teach the course again, I would try to create an integrated approach to getting geometry in there, at least some of it, to help support the students better. So you'll notice that I have a pre-post. So on the right-hand side is the percentage the students got when they came in. 42% got this item correct, and exiting 69%. Not exiting, this is mid, right? So we still have 4 more weeks to go. Mid, 8% got this correct, 92%. Now this is a big shout out because, well, it's also the last thing they saw before they took this was absolute, but we did inequality and then absolute value inequality. So this is still fresh in their mind. Now, do they retain it? We have to see that later, right? Because they did very well on this after that. Also, note that 100% of my students took this now and 38% omitted it before. So they feel comfortable now to do this problem. And then this last particular problem, 36% got it correct, 4% omitted it to begin with. It went to 73% now, definitely a lot less, 15% choosing A still, and 4% still omitting it. So these are still students telling us that we have some challenges. Luckily for me, in this bridging program, we had a lot of supports. We had supplemental instruction, we had content tutoring. So I was able to, at this point, still see students are challenged with content we've done. I need to arrange some sort of extra supports, whether that be a school level support and after school support. Your data will tell you what you need. And what teachers, we can't do it all by ourselves. We do need the administrators and everybody else to help design programs to support students who may still find challenges. A lot of things to look at here. So I want you to focus this. This is a pre-post. I did tell, somebody asked a very good question. How do we know students that were in this course? Students that do not come in with AP or IB calculus scores to move them into a calculus class or higher, they need to take a placement test. So this is the results of the 2020 cohort. So we had 2,092 students take a placement test that year coming into, and these are students that are first year incoming students coming to UC San Diego. So what we're going to focus first on is that very first column is my students that took this before they took my bridge program. So this is the pre-bridge students. And then when the second column is when they left. So they took the placement test before they got to me, and they had to take the placement test again before they can be moved on to that pre-calculus class. So you'll notice we're going to focus on that second column. The third column would be all students that were going into the pre-calculus class that placed into that class, 622 in the fall. So we're comparing them on the third column. The last column would be the whole cohort. So this includes students that were placed all the way through a STEM Calculus 1 course. So all the student cohort. So these are also their percent correct, average percent correct on each of the topics on that placement test. So I'm using the P word here because we do use placement in post-secondary. We don't use the P word very often in secondary world, which you'll see when Emiliano and I talk about this in our session. Is there something in the chat?
Deanna just shared a link for where the modules are located.
Perfect. Awesome. Thank you, Deanna. Okay, so we're going to really focus on these second columns because pre-post, these are my students. Pre-post. So second columns are their readiness when they exit after they finish the bridge and they're ready to move into the fall course. We're going to compare them to everybody else. So also going to look at what I focused on, linear, exponential, quadratics, functions. So I'm going to look at linear, exponential, polynomials, quadratics, this is polynomials, and functions. I'm going to look at the functions because that's part of the umbrella, right? So you'll notice that in all the cases here that the students gained in each case, and particularly linear, they gained. And you can also compare them to the readiness of the students who are placing up all the way through calculus readiness. But specifically, they have pretty similar readiness to students going to pre-calculus. Which is what I'm really looking for. I want them ready for pre-calc. If you look at exponential functions, they are as ready as everybody. So I feel very good about them doing well in the pre-calc. And in fact, some students, I'm not quite sure exactly how many, some students placed into higher course than pre-calc. They went in after the bridge, they were able to get into the calculus course. Polynomials, they did very well there also, made huge gains, and then we made great gains also, the best gains in fact, in functions overall. So their concept and their understanding around function. Noticeably, we also made gains in rationals. And even though I didn't focus on rational expressions, because we had done so much work in fractions and understanding the concept behind fractions, you can see that they are doing well there also. In fact, they've gained in all topics, even the ones we didn't talk about at all. So I'm very pleased with my students. This is, so that's my results I'm sharing with you. We have tons of really great resources. This is the recommendations for testing and suggested uses. These are all on our website. We have 6 guidelines to inform next course enrollment options, which Emiliano and I will talk about. We put together a webinar series last year, so we have all of these things also posted on our website for last year's webinars for specific things that you might be interested in. And then you are here on March 12th, but we're also doing this again on the 26th for any of you that want to come back. So if you liked what I did in my keynote, what you could do is you could tell your friends, come back and see the keynote, and then they could pick, if they'd missed today, they could pick another session. If you're here to see all 3 sessions, you saw my keynote today, you do not need to do the keynote on the 26th, as I'm going to be repeating, but you can do 1 session today, and you can do another breakout section on the 26th. So there we have it. Here's our breakout sessions for coming in. And I think that's my, let's go ahead and go into the, check out the chat. So all sessions are recorded. Yes. And I think that's it. So do we have any, oh, I do want to explain here how the sessions are going to work. And I think I'm going to be able to let you go a little bit early. If you stay in this Zoom, you will be staying with Emiliano and I, because we have the same session. If you come back for the question and answers, it's also this session. Pat and Carol get their own special session, and that's because we need to break away and have some of you guys when you join Pat and Carol, so that make sure you get that Zoom session if you want to go to theirs. And at this point, I'm just going to take us into our website. The website has everything that you need to know. So resources, our conference, our webinars. This is something I talked about, the webinars here. We have, we ran, I think, 8 webinars last year. 1, 2, 3. Yeah, 8 webinars last year. They're all on here. It tells you the topics, the presenter, the presentation, a PDF. So we'll also have the presentation for these slides. Besides it being recorded, we'll have it posted just like this. And then our resources for that. So it's a video recording and the documents, each of those. If you want to order test, go to either Assessment of Preparedness or the 9th grade assessments. We have those here. And we also have them described the topics on the test and how we kind of give an overview, right? And if you scroll to the bottom, you will get these resources for best practice. And this one's the one that I talked about, recommendations for teaching. And I think I'm just going to jump that in the chat right now because this is a great one here, which starts from grades 5 and it goes through, let me see here, copy, sorry about that. It goes through grades calculus readiness. And I'm going to give it to everybody. There we go. Okay, so you want to get straight into this particular document. This document's great because it talks about exit and all the way through. So if you are working with elementary students that are matriculating from their 5th grade to 6th grade, this gives you some ideas of the assessments you could use. Again, we do that for each level. So from 8th grade to 9th grade. And then also you just saw something, a matriculation from high school to a college course, which is the bridge program. So we have things like that too. Okay, I'm going to stop sharing. And if anybody has any questions that they want to ask real quick before we break, we have about 3 minutes and breaks are for you. So Carol and Pat will, and Emiliano and I will start at 10:30. Any questions?